Okay guys, our new topic is looking over index laws, and majority of this we did last year, so it's basically just revision for you. The first video that I'm going to present is just revising the first and the second index law, which you can see on the OneNote page here. With the first index law, if we're reading here, so if we're looking just here, when the bases are the same, so when the bases are the same and it's a multiplication sign, such as here, then you simply add the indices. That's index law 1, noted there. For index law 2, if the bases are the same and it's a division, then we subtract the indices. So that is revision from last year. Let's now look at some basic examples to just refresh our memory. So the first example, if we have m to the power of 6 multiplied by m to the power of 2, the bases are the same, they're both m's, and it's a multiplication between them, so we add the indices. We say it's m to the power of 6 plus 2, which gives us m to the power of 8. Second example to look at, 2y to the power of 5 times 3y to the power of 6. What we do here is we look at the coefficients, or what we've called the big numbers. So we get 2 times 3. So we times those numbers together, and with the y's, it's y, bases are the same, and it's a multiplication. So index law 1 says that we add to those indices. So our answer would be 2 times 3, which is 6, and y to the power of 5 plus 6, which is 11. So that's a revision of index law 1. Index law 2, p to the power of 7 divided by p to the power of 4. So again, our bases are the same, it's a division in between. Index law 2 says that if the bases are the same with a division in between, you subtract the indices. So it would be p to the 7 subtract 4, which is p to the power of 3. One further basic example, 12n to the power of 7 divided by 4n to the power of 3. You may remember from last year, I actually like these to be written like this. It's not essential, but I just find it easier. Then what I do is I look at the big numbers, the coefficients, and I can cancel. 4 goes into itself once, 4 goes into 12 3 times. So we've got 3. I then look at the n's. It's a division, so it's n to the 7 take 3, because index law 2 says for a division you subtract the indices. So our answer there would be 3n to the power of 4. Okay, now we're going to look at the actual worked examples that your textbook does. Those were just some basic ones to refresh your memory. So these ones here are what your textbook has. So worked example 1. Exercise 1.2, worked example 1a is here. I have rewritten it, and you can see what I've done is I have highlighted where the bases are the same. So in yellow, I've highlighted anything with a base m. In green, I've highlighted anything with a base n, and in pink, anything with a base of p. So then what I do is I look at my m's, and I say it's m to the power of 4 plus 2, index law 1, add the indices. N to the power of 3 plus 5, p to the power of 1 plus 3. Okay, a common mistake is forgetting that it's not nothing up there, it's in fact is a 1. So then it would be 1 plus 3. I then say m to the power of 6, n to the power of 8, p to the power of 4. Looking at worked exercise 1.2, worked example 1b. Again, I've copied it out and I've highlighted where it's green base A, pink base B, and yellow for the coefficients. So my next step, it's 2 times 3. Then I look at my a's, it's a to the power of 2 plus 1, because there's a 1 there, b to the power of 3 plus 4. So one last step, 2 times 3 is 6, A, 3, B, 7. Okay, worked example 1C. Again, I've rewritten it. You can see that I've highlighted the things that we need to do together if you like. With the 2 and the 10, I can say 2 goes into itself once, 2 goes into 10 5 times. We then have 1 and 5. With the x's, I have x to the power of 5 take 2. Index law 2, if it's a division, I take the numbers. Y to the power of 4 take 3. So one last step, that gives me x to the power of 3, y to the power of 1 over 5. And remember, you may see this written as x to the power of 3, y over 5. That's the same thing. Here, if there's nothing written there, then it's not a nothing, it is 1.